The previous demo, obviously, in circuit was incorrect because it doesn't protect our Arduino from overdrawn current. And I want to fix that by coming back and creating an updated circuit, an improved circuit. In this circuit, we're going to use a 12-volt relay to drive the same 12-volt LED strip. Obviously, the Arduino can't provide 12 volts, but more than that, the Arduino can provide the current that this relay needs in order to close the coil and energize the coil. So we need to deal with that by using a transistor, which will be able to drive 12 volts into the coil using 5 volt switching from the Arduino. Let's talk about the relay first. The first thing we need to do is to calculate how much current we need in order to energize the coil. And just like in the first demo, what we need to do in order to figure that out is to calculate is to first measure the resistance of the coil, and from that use Ohm's law to calculate the amount of current that we need to flow through it. So I've got my multimeter. It's set for resistance measurement. So let's check out how much resistance we have in the coil. There's 406. Okay, 405, say. I'm going to go to my calculator, and for resistance, I'll plug in the value 405. Now, I know that I'll be giving this relay 12 volts from my power supplies, since it's a 12-volt relay. So I've already got 12 volts in my calculator, and that gives us about 29.5, let's say 30 milliamps of current through the coil. All right, so now we know that we need to provide 30 milliamps of current in order to energize the coil. We need to get the power from the power supply when the Arduino says so. So for that, we're going to use a transistor. This is an 2N2222 NPN transistor. I talked a little bit about transistors in the TIP 122 lecture. And back then I said that essentially you can think of a transistor as a switch, a solid-state switch. The pin in the middle for the transistor with this package is called the base. When you want to make a connection between this and this pin, this is the collector. This is the emitter on the left, and this is the collector. I'm just looking at the schematic. You need to send a signal to this pin. Now that signal is really an amount of current that will flow through this pin and will cause the other two pins, the collector and the emitter, to create a connection between them. So I need to next figure out how much current I need to allow to flow through this base pin. Now, if I allow too much current to flow through the base pin, I'm going to burn the transistor. It's exactly the same thing that happens when too much current flows through an LED, and that's why we use a current limiting resistor in order to protect the LED. So, same thing here. We need to calculate the value of the resistor that will both protect the resistor from burning out and allow for enough current to flow through it so that we've got an electrical connection between the other two pins, emitter and collector. So, how do we do that? It's pretty easy. What you need to do is to expand a little bit your understanding of what a transistor does by thinking of it as, in a way, a current amplifier. So essentially, you are putting a little bit of current in the base, and you get a lot more current from an external power supply between the emitter and the collector. And there's a relation between these two currents, the one in the base and the one between collector and emitter. So we call the ratio between those currents, we call it gain. And the formula is that, going into my calculator, H stands for HFE, C stands for IC, which is the current in the collector, and B stands for IB, which is the current in the base. So the gain, H, is equal to current in the collector divided by current in the base. I know how much the current in the collector should be because the collector will provide current to the coil. So I calculated that this is, say, about 30 milliamps up here. And what I need to find out is how much is the current in the base supposed to be. So I need to solve this for B. So B is equal to C divided by H. Now, one thing that I need to find out is how much is the H. And for that, I need to look up some documentation in the datasheet for this transistor. So here's a datasheet for the transistor. I've got a link to this in the lecture notes. So if you scroll down to look it up, there should be an entry for this. There you go. So it says HFE DC current gain, and it's got a few different ratings. The one that I'm going to pick is the one where IC and VCE are closest to my circumstances. So VCE is the voltage between these two pins, the collector and the emitter, and that's going to be coming from the power supply. So that's going to be 12 volts, close to 10, not exactly 10, but close to 10. And the IC is 10 milliamps. I'm looking for 30, but again, that's not too far. And I'm not looking for super accurate calculations here. I'm looking for a ballpark calculation, since transistors themselves, the way that they're manufactured, are not that accurate unless you go for very expensive ones. This one isn't very accurate anyway. So the number that I'm looking for here is this. This is the gain, 75. So I'm going to take this number and put it in my calculator. So I'm going to say that H equals 75. The C, the C, I'm going to get it from my previous calculation to be 30. So this is really 0.03. So that finally gives me an idea of what the current in the base is going to be. So B is equal to 0.004 or 0.4 milliamps. The last thing I need to do, now that I know how much current is supposed to flow through the base, is to calculate the current limiting resistor. Remember, if I don't provide a current limiting transistor, I'm most likely going to burn my transistor, since a lot of current is going to flow through it. And I had a lot of cases like that. So this is a transistor I destroyed earlier exactly by not providing a current limiting resistor. So let's go back to Ohm's law, and the resistor that I'm looking for, I'm going to call it R, equals to the voltage. Voltage is going to be 5, because that part of the circuit is powered by the Arduino. So 5 volts divided by how much was it? B by B, right? So 0.004 ohms or 0.4 milliamps. So eventually I find that my current limiting resistor should be around 12.5 kilo ohms. So I'll go for something like 12 or 13 or something like that will be good enough. So that's how you calculate the current limiting resistor that will protect your transistor. So we've got everything we need now, so we can go ahead and put this circuit together.